All right, class. In this lesson, you're going to learn to find the points of concurrency or intersections for the altitudes of a triangle. Okay, let's go ahead and get started. So first, let's go ahead and define what an altitude is. Okay, so as you can see, the altitude is the perpendicular segment from a vertex. So in this case, we're going to start from vertex A, and it's going to extend to the opposite side of the triangle. So opposite side of this vertex is side DC. Okay, now if I extend this out inside the triangle, we are not going to be able to create an altitude because the altitude has to be perpendicular to the side DC. So we're going to extend this side out, and now we can go ahead and extend the altitude out. So this altitude comes from the vertex to the opposite side of the vertex at a 90-degree angle, creating a perpendicular angle. Okay, so AE is the altitude perpendicular to DC. All right, so let's go ahead and start with the first theorem. Okay, there are three potential altitudes in a triangle. Okay, and when you create those altitudes, they come together at a concurrency or in intersection, and this intersection is called the orthocenter. Okay, so KQ is an altitude, LN is an altitude, and then NP is also an altitude. Okay, so all three of these altitudes are concurrent or intersect at point X, and this point X is called the orthocenter. All right, so how do we locate the orthocenter? Okay, so the orthocenter can take place with three different kinds of triangles. The first one, I'm going to start with the right triangle. And if we go ahead and sketch this out, okay, and sketch a right triangle, and then create altitudes for all three vertices, we could see that this altitude extends out from the right angle to the opposite end, creates a right triangle. Okay, then from this vertex here, it hits the opposite side at exactly 90 degrees, and then from the last vertex to the opposite side at exactly 90 degrees. Okay, this intersection is my orthocenter, and this happens to be at the vertex of the right angle. Okay, so that's one location of an orthocenter. Now let's take a look at what happens with an acute triangle. Okay, so here's an acute triangle where all three angles of a triangle are less than 90 degrees. And if we go ahead and draw the altitude, so from this vertex to the opposite side, go ahead and draw a right angle here, and then from this vertex here to the opposite side lands us right here, and then the last one from that vertex to the opposite side lands us right about there. Okay, so here is the orthocenter, and what we notice is that with an acute triangle, the orthocenter is inside the triangle. Okay, and then the last example, we're going to go ahead and draw an obtuse triangle. An obtuse triangle has one angle of the triangle that is greater than 90 degrees. Okay, so this angle happens to be 90 degrees, greater than 90 degrees. So if we were to draw an altitude from this vertex to the opposite side, we can't create a 90-degree angle, so we're going to need to drop that down over here. Okay, so let's go ahead and extend this out, and I'm going to just make this dotted so that you see that it's an extension. Okay, so if we go ahead and draw the altitude, that lands us over here at 90 degrees. Okay, and then from this vertex, we can go ahead and draw another altitude to the opposite side. And that takes us right about here at 90 degrees. Okay. And then the last one, we have this vertex. We want to extend it to the opposite side, but we're not going to be able to create a 90-degree angle. So we actually have to go down here. But let's go ahead and extend this side out so you could see what this looks like. And I'll make this dotted so that you know it's an extension. Okay, so if we go ahead and draw the altitude, let's make this 90 degrees right there. Okay, all right, so we see that they don't quite intersect yet. However, we can go ahead and extend each of these altitudes out further, and you'll see then that they actually do intersect. Okay, let's go ahead and take this and extend this, out to here, and then go ahead and take this and extend this out to here. I don't think I have quite the right angle here. I think this one should come down to about there. Okay, so here's the orthocenter right here. Here's the orthocenter, and as you can see that the orthocenter in an obtuse triangle is located outside of the triangle. Okay, so in summary, the orthocenter, let me go ahead and zoom out a little bit. The orthocenter is outside an obtuse triangle, okay, as we showed over here, and inside an acute triangle, as we showed over here. And then for a right triangle, which we have here, the orthocenter is at the vertex of the right angle. Okay? All right, so let's go ahead on to the next example. Okay? This one's a little bit extended, but hopefully you'll bear with me to find the orthocenter of this particular triangle. Okay? So we have this triangle at point 0, 0, 3, 12, and 10, 5. Those are our vertices. So the first thing we want to do is find the slopes of two sides of the triangle. Okay, so we're going to find the slope of side KL. Well, what is the slope? What is the equation of slope? The equation of slope is y2 minus y1 over x2 minus x1. Okay, well, let's take a look at KL. Okay, KL. This is my x2 and my y2, so I can go ahead and substitute or throw in y2 into this equation. So this is going to be 5 minus, what's y1? Well, my y1 here is 0, so we're going to say 5 minus 0, and then x2 is 10, and my x1 is 0, so that becomes 10 minus 0, and this works out to 5 over 10, or exactly 1/2 as our slope. Okay, so slope of KL is 1/2. Now let's go ahead and identify the slope of LM. Okay, LM right here. We want to find this slope. Okay, so again, the equation for slope is y2 minus y1 over x2 minus x1. Okay, so then this becomes 5 minus 12 over 10 minus 3. Okay, 5 minus 12, this is y2 minus y1 over x2, which is 10 minus x1. Okay, so it doesn't matter if we call this x1 y1 or this one x2 y2. What matters is if you go in this direction, right? If you go 5 minus 12, then you have to go 10 minus 3. You can't go 5 minus 12 and then 3 minus 10, going in the opposite direction. That you cannot do. Okay? All right, so in looking at this simplifies to negative 7 over 7, which equals negative 1. Okay? So now we know that the slope of LM is negative 1. All right, so step 2 is going to be using the point slope form to write the equations Okay, point slope form for the equation of what? We're going to write the point slope form for the equations of the altitudes. Okay, so let's pause here for a second. First, we found the slope of KL. Okay, KL is over here. So then the altitude that relates to KL will be from vertex M down to about here. Okay, so we want to find the equation of this line. Okay, and how do we find the equation of that line? We're going to use the point slope form to write that equation. All right, so what is the point slope form? Point slope form is y minus y1 is equal to m times x minus x1. Okay, so then our equation is going to be y minus, and I'm going to leave that blank for a second, and we're going to leave this blank as well. Okay, so what is my x1 and y1 for this altitude? Well, the only point on this altitude that's given to us is 312. So we can go ahead and throw this x and this y into this equation. Okay, so what that means is y1 is 12 and x1 is 3. Okay, now the last piece we need is our slope. Okay, we solved for our slope for KL to be 1/2. Okay, 1/2. But we need the slope of the altitude. Well, the altitude is perpendicular to KL. So to find the slope of the altitude, you're going to take the negative reciprocal, meaning instead of 1/2, it's now going to be 2/1, and we're going to negate it. And 2/1 negated simplifies to just -2. Okay, so now what we've done is establish the equation of the altitude. Now we need to do the same for another altitude. Okay, now we found the slope of LM, which is over here. So then the altitude related to LM is going to extend from K and hit LM at a right angle. Okay, so then the equation for this altitude that we just drew is going to be, and let's go ahead and just fill out what we can for now. Okay, and the first thing we want to do is find my x1 and y1. Okay, so let's take a look at this altitude. What point do we know on this altitude? Well, the only point that we are given is right here, 0, 0. So we can go ahead and substitute x and y for 0 and 0. All right, and then the last piece we need is this m, okay, the slope. Well, we found the slope of LM, which is here. Okay, this slope was -1. To find the slope of this perpendicular line, we would have to find the negative reciprocal. So if we take the reciprocal of -1, it's still -1, and then we take the negative of that, so a negative of a negative is a +1. So then my slope is 1. Okay, so this then simplifies to y is equal to x. Okay, so now we've established two equations. This is equation 1 and this is equation 2. Okay, so then step 3 and our last step is solve the systems of equation. Okay, we have the systems of equation because we have one equation with two variables and another equation with two variables. Okay, and in solving the systems of equation, one of the things we can do is use the substitution method. And what this means is, because we know y is equal to x, okay, y is the same thing as x, we could take this y and replace it with x because we know y is equal to x. Okay, so in rewriting equation 1, we can say that x minus 12 is equal to negative 2 times x minus 3. Okay? So hopefully you see that instead of writing y, which should have been here, we replaced it with x, and we're allowed to do that because we're told that x is the same thing as y. All right? So now we can go ahead and solve for x because that's the only variable left. So let's go ahead and do that. X minus 12 is equal to negative 2x plus 6. Okay, how did I get that? We have to distribute negative 2 to the x, so this is negative 2 times x, and that's what we get here. And then distribute negative 2 to the negative 3, so negative 2 times negative 3 gives us a positive 6. Okay, next thing I want to do is move this negative 2x over to this side of the equation, and we do that by adding 2x to both sides, and this results in 3x minus 12 is equal to 6. Okay, and then we want to move this negative 12 to the other side, and to do that we're going to add 12 to both sides, and when we do, we're left with 3x. These cancel out on this side of the equation, and on the right side we get 18. Okay, and then the last step is we want to eliminate this 3, and we do that by dividing 3 on both sides. And when we do, these 3's cancel out because they become 1, and now x is equal to 6. Okay, so remember, we're looking for the orthocenter of the triangle, so we need to know the exact coordinate here. We just figured out that x is equal to 6, okay, and all we need is y. Well, we know from equation 2 here that x is also equal to y, and if we know that x is equal to 6, then y is equal to 6. Okay, so then our orthocenter, is going to be 6, 6. Okay? All right, hopefully that made sense. I know that was fairly involved, and I went through that potentially a little quicker than you're able to digest. And so I would recommend that you go back to the beginning of the recording and listen to this again for further clarification. Thank you.